Thank you. First of all, thank you to the Finder Group for inviting me to participate in this really critical juncture in our world. My name is Paksy. So I led a team of, so to begin with, I'm not in the social sciences, humanities camp, or tech camp because I'm in both. So you can't like blame me for one thing or the other. But I led a team of AI experts and talent acquisition leaders from startups and also from public corporations. And so what we did was, in essence, we mimicked a job hiring process to stress test algorithmic hiring software. So basically ATS, application tracking systems. And we did this with the Berlin community, German applicants, more than 80, or it was 88. We also interviewed a whole slew of very renowned, prominent American software companies in talent tech. And I can share with you the names later on, and a number of focus groups. So we did a truly qualitative experiment and quantitative experiments. So these are some of our findings. There is nothing new to you. No need to apply. These are just some of them we have seen over the years, right? You know most of these. Your resume is formatted incorrectly, we saw in our systems. You get tossed out immediately, even though you may be the best qualified candidate for the job, just because of that reason. So we found a number of these things. Most notably, we found that in our data set, there were a number of category C job applicants, so the least best for the match, or the least best match for the job, were selected by the machine over category A candidates. So basically, you may be the best qualified, even from a, not just experience and skills, but from like, you have the certification, the education, you're our top candidate, but somehow the machine said, no, we prefer these candidates. And they were the least, they were favorable by the machine, but the least qualified. And then also notable, and this is why all of these discussions today, this is the complexity. You can say, this, and this is what we found, you have Indian applicants that have a lower scoring by the system if you apply in Germany, right? Same job, same CV. But if you're in the UK, the attribute of you being from Indian descent, your ethnicity or your name, your foreign experience and your foreign education, somehow now is higher scored. And that's, of course, because of the LLM and how the system has learned over time. And because we have a larger population in the UK that has been successfully integrated, now these CVs are treated differently. So that's why you can't say intersectional discrimination, these groups are always being discriminated against, because it just depends, and we had this discussion before, it just depends where, on what model, for what, purpose, for what, so it's, I didn't want to throw more kind of complexity, but this is what we're facing. So we're losing millions of hidden, talented people sitting by the sidelines. Just in Germany alone, we're looking for almost 3 million people, and it's not all because of, obviously, algorithmic hiring systems, because in essence, hiring has always been biased, as we know, because us humans, right? So if you solve the tech challenges, you're not solving the whole problem, right? But if you do not solve the tech challenges that we're having, you will exacerbate bias discrimination at scale, fast, and that is the problem. So I invite you to check out our report. It's 100+ pages. It was concluded with not only the job applicants and the experiments we conducted, but also, like I said, with renowned corporations, public companies in Germany, talent tech companies, and also with a number of other experts from known companies. And we worked, for example, to just give you a flavor, we worked with, for the quantitative part, we worked with the VP of Diversity Inclusion, HR Director at Deutsche Telekom, and then we also worked with a number of AI startups for the stress test. That's it. Thank you.
Hello everyone, I'm very happy to be here. My name is Eirini, I'm a computer scientist and I'm one of the PIs for the MAMMOth project. And I want to use this opportunity to reflect on the complexity of the AI fairness-aware learning, so whether you are tackling real-world complexity, so it's like a reflection exercise also. And there are many different aspects of this complexity, so I will focus on only a few of them, also because of the time. The first one is regarding the modality of the data, what type of data do we use. The second one is regarding the protected attributes. Do we focus on single discrimination or multi-discrimination? And the third one, a bit more generic, is whether fairness is the only objective and whether we need to look also at other desiderata for responsible AI. So let's start with the first one. Okay, great. I didn't manage actually to reduce the text in my slides, I'm very sorry. It didn't work this time, right? So as you know, there is a lot of work on fairness-aware learning. So there are a lot of methods for bias detection and bias mitigation, or debiasing or unbiasing and so on. But most of these methods actually focus on tabular data, right? So we have a lot of methods for tabular data, but what we lack still are methods for more complex data types. For example, graph data, image data, textual data, multimodal data, and so on and so forth. Because in the world we have actually these modalities, and of course multimodal data. And despite the fact that there are some methods for these different modalities, so beyond the tabular data, many of these works actually what they do is that they transform the data into tabular data, and they exploit a huge body of work from the tabular domain. So the question is whether we miss something by converting the data modality to the tabular data modality, whether we miss something from the complexity of the data. And the second is also the similar problem, right? So many of the fairness measures that we employ, they also rely on measures that we have for the tabular domain. For example, for graph data, like in the example up there, a popular measure is the so-called balance score, which focuses on the representation of the protected and non-protected groups in each and every cluster. So it focuses on the nodes, but it ignores the connections, right? So it ignores the IID, non-IID property, which is the main property of graph data, right? So it's really important to scale up the complexity in terms of modality. Let's move now to the second one. So another aspect of complexity, protected attributes, right? Again, there are a lot of works which focus on single-dimensional discrimination. So discrimination, the presence of a single protected attribute, even binary attributes, right? But in the real world, we know that human identities are multidimensional. So we have gender, we have race, we have color, we have ethnicity, and so on and so forth, right? So we have many identities, and many of these identities are protected, and discrimination can be the result of the interaction of many of these identities. So it's really important to look at more than one, so to move beyond single-dimensional discrimination. And actually there are a couple of works in this direction, for example from the laws. There are different concepts of multidimensional discrimination. Some were mentioned today, for example intersectional discrimination, but it's not the only one. Right? There is also cumulative discrimination, there is also sequential discrimination, which makes a lot of sense, especially in pipelines, machine learning pipelines, which consist of many different components interacting with each other. So it's really important really to look at this combination of more than one protected attributes. And it's not an easy task. Unfortunately, so there are a lot of challenges. The main challenge is the so-called fairness gerrymandering problem. So you cannot really look at each of these dimensions in isolation because many of the problems occur in the intersection, right? For example, black women of a certain age and so on and so forth. And also, as we increase the dimensionality, we have a lot of imbalances in the data, population imbalances, so different groups have different cardinalities, and if we focus on supervised learning, we have also extreme imbalances in the minority class, as you see in this example here from the adult data set. So the black young females, for example, is a tiny group, so it's really difficult to learn something from this group because of the cardinality. And of course, we don't have benchmark data sets for all these different definitions of maladiscrimination, and I'm very happy that a lot of new data sets are created in the context of this cluster. And last one, right? And I know this is an event about fairness, right? So fairness is something that we all care about. But I think fairness is not the only objective in responsible AI, right? So of course, it's a very important aspect of responsible AI, but it's not the only one. And also today in the discussions, privacy was mentioned. I can add also explainability or resilience to adversarial attacks and so on and so forth, right? So there are a lot of desiderata for responsible AI, and in many of the applications, actually, we need to fulfill all these different requirements. And the problem is that the more requirements you add, the more difficult the optimization, let's say, problem or the learning problem becomes. But I think it's super important to really consider these aspects jointly, especially since there are studies which show that fairness enhancing interventions actually might lower the resilience or the privacy of the system and might affect different groups in different ways, right? So we create another unfairness problem with respect, for example, to privacy and resilience to attacks. So joint tackling is necessary, and even if we don't jointly tackle all these problems, I think it's really important in our evaluation to also assess how the interventions that we do for fairness impact other important aspects like privacy or whatever is important based on the particular context. And many more aspects of complexity, right? So this was just a small sample. And yes, it's a call for action also to scale up the complexity. So let's look at more interesting and difficult problems. So thank you very much.
Thank you. Good afternoon. My name is Catelijne Muller. I'm president, co-founder of ALLAI and part of the AEQUITAS project of this cluster. I have a legal and a policy background, strong policy background, and I'm going to talk today a bit about that. I was a member, which one do I use? Yeah, I was a member of the high-level expert group on artificial intelligence to the European Commission already in 2019, I think, and that is where I started the discussion on responsible artificial intelligence. Even before that, I won't go into that, but that is where we decided as a group that AI does not exist in a value-free world, and that we need to look at the ethical implications of that. So that is where the ethics guidelines for trustworthy AI came from. What was interesting in the ethics guidelines, you will see that they are based on 3 pillars, and the first pillar is lawfulness, because AI does not operate in a lawless world either. So what we decided that apart from ethical principles and ethical values that we need to take care of in the ethics guidelines, there's also regulation already existing that needs to be taken into account when you use AI systems. This morning, I think Joanna Goody, who was also a member of that group, talked about the Charter of Fundamental Rights. But you can think of a lot more. We are talking here about fairness today, but you can think of a lot more regulation out there that is also relevant or that has flown from the European Charter of Fundamental Rights. Equality and non-discrimination directives, for example, but also the Unfair Commercial Practices Directive that is aimed at businesses, for example. The GDPR, that we all know, is a very important one. And then there is a lot of national laws that deal with fairness some way or another, that apply also to the use of a tool such as artificial intelligence. There's new regulation also out there. Last week was a big week at European level. The EU concluded almost the AI Act that you have probably all heard about, and Europe, which is a group of a larger member states, 47 member states, concluded a first preliminary version of the AI Convention of the Council of Europe on Artificial Intelligence. So what we found in this project, in AEQUITAS, and also in all the other work that we do, is that fairness is more, you've heard that also from the previous speaker, fairness is more than just non-discrimination. It is about non-discrimination, of course, based on attributes. And what is important that you need to remember that the law says discrimination is not allowed based on attributes such as. So it's not an exhaustive list. And it mentions attributes that you all know: age, race, sex, color, but also language, religion, political, or any other opinion. You cannot discriminate based on someone's opinion. What does that even mean? And then also the text such as. You cannot discriminate, I don't know, single women. They are not in the list, but you cannot discriminate them because they're single women. Fairness is also about, if you look at it from a legal perspective, elements such as the right to a fair trial, for example, or the right to a reasonable suspicion. If you look at predictive policing, for example, people are selected by predictive policing algorithms not based on an actual suspicion, but based on the fact that they share a characteristic with somebody else. Is that a reasonable suspicion? That is also a question of fairness. And the last one, and I find this interesting, this comes from Sandra Wachter, that you probably all know, is what about reasonable inferences? What about the fact that in the famous Dutch case, the Toeslagen case, a single mother over 15 with a 15-year-old child living in the home was considered a high risk of being a fraudster? Is that a reasonable inference? Is that fact reasonable? Is it relevant to flag this woman? There is also a large challenge of automating fairness from a legal perspective. Because despite what maybe some people think, the fairness rules in the law are not black and white. They are general in nature and they're open to interpretation. So they're fundamentally contextual. They are interpreted by judges on a case-by-case basis who take into consideration the circumstances of the case. And this is not something that AI systems can necessarily do. Also, what we've been hearing a lot is people asking, can you give us some sort of a threshold? I know that mathematicians like to work with numbers. From X% on, it is unfair, and below that, it is not unfair. That is not how the law works. There are no legal thresholds for fairness. And AI cannot do what judges and lawyers do, and that is interpret a case, an issue, based on the circumstances of the case, based on whether somebody shows remorse or not. That is not something that a system can do. I was asked to keep it short, so I'll keep it at this. And if you have any questions about the AI Act, you can ask me anything, because I know it by heart by now. Thank you.
Thanks everyone for inviting me. I'm Krishna Gummadi. I'm a computer scientist by training. So since this is meant to be a very short talk, I thought I would focus it entirely on one problem that I felt sort of we didn't manage to solve, even though we spent a lot of time on it, and I'm hoping that maybe some of you might find this problem interesting and might spend a little bit of time on it. So, so since the theme of the panel is AI-powered decision systems, there are different ways in which you could think about unfairness and biases that arise. We have already heard about how when AI systems are making the final decisions, there are a number of problems here. There's another type of systems where AI systems are increasingly being put into use with humans in the loop, above the loop, under the loop, and so on. But the problem that I wanted to focus on is the third one, which is oftentimes when you're talking about decision support systems like in employment or housing or recruiting or whatever, you have a notion of a pool of applicants for the position. And you're trying to be fair in your decision making across that pool of applicants. But the pool itself is already a subset of a whole bunch of population out there. And this is some problem that arose in our context. We constantly look at our recruiting, and we run a number of different programs, PhD programs, internship programs, summer schools, and we have consistently found, and I'm working in Germany, we consistently found some very striking localized patterns. There are people from certain schools, certain countries that apply, and others that don't. Why? We never quite understood. So a few years ago, I started playing with trying to do this outreach in a broader way, and we started running some ads on social media sites to reach out to people in the hope of contacting more people to make them aware of some summer schools that we were running. And this was in Europe. And we ran immediately into a problem. And that problem is, actually discriminatory advertising or discriminatory micro-targeting. You may have already heard about this. So typically advertisements are often about selling products, detergents, cars, and nobody thinks of discrimination in those kinds of situations. But there is a category of advertisements which are related to opportunities, and they are called opportunity ads. These are things related to employment, housing, and banking services and financial services. For these kinds of ads, it's actually considered an opportunity for people to be aware of the chance to apply for them. And this is the context in which discrimination can arise. In the US law, these are things that have been identified. Now, you may have seen a number of different types of articles like this where many social media sites were supposed to have allowed advertisers to target job ads, housing-related ads, financial services ads, only to certain genders or certain age groups or certain races. And this is very problematic. But the theme that often when you see this is that the advertiser is malicious. And therefore, as a result, if you looked at the solutions that have been proposed, they're mostly about one type of solutions that have been proposed is to make the ads public. There are a lot of public ad libraries so that others have a chance to look at them if they wanted to. And the second thing is focusing on micro-targeting. So let's try to quickly understand the two reasons why discrimination arises. The first, and this is the one that most people focus on, is the micro-targeting of ads to narrow segments of the population. And what we mean by that is Facebook, and for that matter all social media sites and internet platforms, have a tremendous number of attributes about each and every one of us. This is a screenshot from the ad API of Facebook, and there are more than 200,000 different attributes that it infers about each and every one of us. The inferences may be wrong, but they do. And so as an advertiser, I can now go and say, I want to target people with this attribute and that and not that and so on, right? So as a result, I can very narrowly target specific subgroups of people. But there is another thing in ads that is completely ignored by most people, including the popular press, and that is about discrimination also comes at a second level of ad delivery within the targeted population. So to understand the difference between ad targeting and ad delivery, imagine if I was an advertiser and I decided to target an ad only to the people sitting on that side of the room, right? That is ad targeting. But when I'm running the ad campaign, only a small fraction of them are actually going to see the ad. Not all of them will see the ad. And that fraction, the precise people, say the 3 or 4 people that are receiving the ad, that choice is made by the algorithms at Facebook and the social media platforms. And those algorithms work by computing what is called as a relevance score for the ad to that particular population. So both these things actually combine to decide who ends up actually seeing this ad. Now there's a really fun study that, actually very careful study that was done by Alan Mislow at Northeastern that actually showed the extent to which this ad delivery can be discriminatory. At a very high level, what he did was he ran 2 ads with exactly the same text, exactly the same content, targeting the same group of people at the same time with the same amount of budget. The only difference being the picture that is included in the ad campaign. So whenever, for certain types of pictures, like the ones here on the left, they are more skewed towards males. More males were seeing the ads, whereas the one on the right was being seen more by females, showing that Facebook algorithms are actually inferring certain things about who would be, for whom the ad would be related or relevant based on images. Now, the solutions, as I was saying today, entirely, even at the legislative level, are focusing on limiting micro-targeting. But this is not going to solve the problem, because they completely ignore a deeper problem of algorithmic ad delivery. To tell you how subtle this problem is, when we ran this ad campaign for our summer school, what we realized was that our campaign was being, for whatever reasons, being delivered more to men than women. And so what we had to do was to actually separate the campaigns, ran one campaign targeting men, another campaign targeting women, so that we made sure that there were equal number of men and women who saw our ads. But if you are limiting micro-targeting, an altruistic person like ours, like we would like to think that we are altruistic advertisers, would not be able to do this. In fact, we would not be able to correct for the bias at the algorithmic ad delivery level. And this has a subtle, and there are many, many normative and challenging questions that come up about it. Happy to discuss this afterwards, but just as a conclusion, over the last 3 years, we worked together with regulators, the Department of Justice, Southern District of New York. The people there brought a case against Facebook on allowing housing discrimination. And I and Alan worked with them, consulted with them, and it is amazing how deep the problem is and how nuanced the problem is. In the end, there was a solution that was worked out and agreed to by all the parties, but it's far from clear whether that is the right one. And happy to discuss later about all the complexities and nuances involved here. And I hope that more people will be able to solve this in the future.
So while the panelists take the seat, there was these few phrases that were repeated several times during the talks, like it's not a solution, it's not going to address a problem, it's not enough, etc. So I love these very critical views that have been presented today. So I have two questions. So my first question is perhaps for everyone, and it's like in many cases this decision support system in high stakes scenarios are deployed in environments in which experts make predictions that have a very large error rate. So think like predicting if somebody is going to become homeless, or if a child is going to be neglected, or if a person living in jail is going to commit a new crime. So the experts are already imperfect. And suppose that a decision support tool makes the expert slightly better, but still has a huge error rate. And I think what we're not considering, something that has been in my mind for long, is like, these systems are very open for criticism because they are trying to predict things that are very unpredictable. But on the other hand, they do help experts make slightly more accurate decisions. But those decisions are going to be far from perfect because we are predicting something is going to happen 2, 3, 4 years down the line. So I think there are voices that say, okay, let's leave the experts alone and forget about adding the algorithm. But if the algorithms make the expert a little bit better, isn't that, and don't introduce further biases, isn't that something positive? But on the other hand, society is going to react to this and going to say, well, your algorithmic system made the expert make this prediction that was wrong, and the prediction will be wrong 20% of the time, which is the same wrongs that the expert, similar wrongs to what the experts are making today. So I wonder if there is any hope to kind of using algorithms for decision support in these high stakes scenarios where the predictions of experts are very mediocre and are bound to be mediocre because there are inherent limits to predictability. That's my first question. If anyone wants to answer, welcome.
There has to be some switch.
Yeah.
Great, thank you.
Yeah, thank you. I've been getting this question a lot, and often in far more simpler terms. When people just say to me, "Well, people are also biased." You make a much better case, much more eloquent. I do see, however, some important issues here, and that is it is not just about getting the system to be just slightly better than a person. What these systems do is that they are, once they are there, employed at scale. And they embed also things. A person if there is a person that is inherently biased towards a certain group, you can take that person aside and talk to that person and change that person's minds or fire the person or whatever you want to do. But with these systems, you run the risks of embedding and, like other people have already said, scaling the problem rather than solving it. Another thing that I wanted to say is, what was it? There's also what we have seen, it's not scientifically proven, but what we have heard from people that was because of the pressures at work, for example, that people tended to follow the outcome of the system due to automation bias and didn't think or reduce the thinking for themselves. So there's a lot more issues around implementing these systems than just asking if it's just a fraction better than a person, then why wouldn't it be great? It has so many more dimensions to it to just say, well, yeah, let's have a better system.
Thank you. Let me be the devil's advocate here. I would say it depends on what do you apply the system for. So what kind of decisions are you using the AI to help you make, what is the decision for, basically? And there's gradation of, okay, you can use it for this because it's pretty harmless, or are you using it for, I don't know, autonomous mobile machines that make a decision on our behalf and act in a foreign territory? I'm thinking of drones, those kind of decisions. So it really depends on what are you using AI for. And then second, I would say it should never be a person, because that person, I don't trust a person, I trust groups of people that maybe form a decision looking at the data or the outcome that the machine suggests. And then you can discuss and deliberate and say, is this the course of action we think as the human, body, committee, or team? And obviously that team, hopefully is made up of different, intersectional, multidisciplinary body of people that you can then look at, okay, is this the right course of action? I'm very I've been in tech many years, and I do think we better work with it. You're not gonna say, okay, we're gonna have to stop this whole game, because there will be corporations that you're not stopping right now. So we better have an answer. So this is my.
I just wanted to, I really like both the previous answers, and I cannot, and I just wanted to re-emphasize and support them. There is this thing that people in the computer science community are talking about as algorithmic heterogeneity, right? Like if you think about the university admissions process, are all the Ivy League schools, when they admit undergrads, are they at a high level from a task perspective? Are they not looking for people who are qualified in some way? But then when you look at the final decisions, which are often done by humans, there are people sometimes that get offers from one and not others, right? And this is because there is heterogeneity in human decision making when people do it at groups. When people interview for faculty positions or jobs, they get jobs from some places and not others, and different places play this differently. And I think we risk losing that heterogeneity, and this is related to the point of scale. Like when you have one algorithm that ends up being widely used and you start standardizing things too much, that's a risk.
Maybe just to add something small, so I totally agree with all the points. I think it's also important to understand why the machines fail and also why the humans fail in this problem, right? So maybe it's a very difficult problem to solve, which I think calls for many problems. But if the machine fails, I think it's important to understand why it fails. So maybe it's bias, maybe it's some shortcut, wrong shortcut from the machine. And I totally agree that if there is some mistake that can be reproduced, for example, then you have this scaling problem. So it's really important to understand why the machine also fails. And a human in the loop is needed in these cases.
And if I may add, I was triggered by what you just said, and you also, what would be really nice is, for example, if we have this homogeneity in an organization, that such an organization can work with a tool that presents the organization with different candidates, that is aimed at, you are very homogeneic in your organization, I will show you some people that you have never thought of before, but that might be very good for this job. That could be a valuable addition to a certain organization.
Can I add on to this? This is actually with the experiment we did.
Yeah.
And you'll be very surprised, or I was very surprised to hear by talent acquisition leaders in different corporations, startups, and public companies that they said, we're very mindful. We give our hiring manager a whole set of very diverse kind of background, and it's up to the hiring manager, and the hiring manager will always still go back to, this seems like a person I can get along with, let's do this. So even if the machine comes with a clever, right, a better, set of choices, you in the end have to deal with a person making a decision. So it's not just a tech problem. This is what I'm trying to say.
Thanks for the answer. Oops, thanks for the answers. We will now take questions from the audience, and I think there's one there.
Hi. Let me make into a tech problem now. So actually, like what Eirini says is just like we need to understand like why the machine fails, right? And like coming to Krishna's presentation, like making the ads, let's say like not personalized, but like targeting all the different groups. Now assume that like we're living in a perfect world, like where the AI Act has been implemented and like companies are following it and algorithms are built in compliance with that. So it's not discriminating in some way. I am like a, let's say like a malign, or like I have malicious, let's say some intent, and I want to attack, right? Like I want to malign some company. And I'm doing some attack while I'm perturbating inside the images, humans cannot understand. Let's say like I will change a pixel or something like that, which will make the model discriminative. Now what you will do in that case? To whom you will go? Will you go to like EU app and say that like, say this is like being attacked, like I don't know why, but like the model is making discrimination. But the model will say, or the like the creator of the model will say, but we have complied with all the EU regulations. Our model is not discrimination. Where do you go then? This is like a tech problem I just like formulated. Can you answer this?
So, I mean, there is a long history of attacks and defenses in design of computing systems, right? Like, so, I'm sure that what you're pointing out is potentially a way in which the system could be attacked, even if it passes regulatory guidelines, right? But that happens all the time. I mean, in the sense that, for example, there are regulations for banking that makes the system better and safer, but it's not a perfect system. There can always be attacks on them, and in that sense, I think what you're pointing to will likely happen, but then people will figure out how to defend against them. There will be more attacks that will happen, and this is a process, right? I see. To me, I never think of this as achieving utopia. To me, the whole reason why the topic of fairness comes in is because you cannot make perfect decisions. If you ever have a system which has 0% error rate, which would be utopia, what do you have to argue about, right? Like, so the thing exists because you have to trade off between different types of undesirable things, and this is a complex society. So, meaning, I agree with your point, excepting that I don't understand I perhaps disagree with the premise that somehow we are ever going to be in that utopian state, and there will always be checks and balances. That's how I see it.
I actually asked this question because in one of my slides, Eirini showed that making fair systems somehow make system also vulnerable. Like for example, say certain subgroups are less robust than the other in terms of perturbation.
Yes, that can certainly happen, and we should be mindful of it, right? It's not pointing out a problem is not I don't see this as critiquing the whole framework itself, right? We always go towards a better society. We would like to believe that every day we're working towards making it better than what it was before, even if it's not perfect. That's the worldview I take. And so in that sense, anything that we do, sometimes will have negative side effects, and we'll have to figure those things out.
Thank you. Let's take another question from the public. Okay, we have two. Let's take both questions and then we answer.
Because I already have lots of questions, so there will be even more. So I'll try to give it to you.
Then let's take yours.
Thank you. So Professor Gummadi kindly asked a question that he thinks should be researched. I'm going to throw the ball back and have a couple of questions for you that I think should be researched. As I told, I work at a regulator, a local regulator, and we have obviously been thinking really hard on, how do we find discrimination in AI machine making. And of course, the first question is, of course, there are lots of things like, hey, should you use AI in the first place? How is the entire process, etc. But if we only look at the, how shall I put it, the algorithmic part, there is of course the question of, hey, how do I compare it? Which metric to use? Second very big question that I have is how to handle proxies. The more I read about proxies, the more I think that everybody means something else by the word proxy, and that makes it really irritating. And then people say, oh yeah, it's a proxy, we can ignore it, but how do you define proxy? And what happens if you throw away all the data because it's all proxies? Another question is, what if you don't have the true label of the subject? Sometimes you have it, sometimes you don't. And obviously, last and not least, is what if you don't have the group membership of the protected attribute?
Is that to me? Okay.
And I would love to work together with whoever is working on it.
So I think all the issues that you're pointing out are exist, and meaning the proxies and the measures. I would only say maybe I hope I'm not getting too philosophical here, but let's just step back and take a look at the bigger picture, right? So recently I was reading a book on monetary policies over the last 70 years or 80 years, right? The financial system, people kept discovering issues and they keep fixing it. And then there are new things that come up with the changing world, right? And sometimes the world changes and there may be completely new types of things that come up. Now, I think one thing that sometimes I fear is that we are being too impatient with respect to how much progress we are expecting within what period of time. I know that many might disagree with this, but I'm just pointing out that, I guess many of the problems with respect to AI, particularly deep learning and the foundational models, they're 2 years old, and at least with foundational models. It's good that we have a very active community of people who are looking at the things and are trying to fix it. But some of these things, would there be a well understood standardized terminology for what is a proxy and this thing? I would expect so. The first books on fairness, textbooks, as opposed to research papers where everybody might use terms in a slightly different way, has come out a couple of years ago. So I do feel like some of these things will be worked out. Maybe it may not be, I'm not saying we should be relaxed about it, but I'm just saying that we should be actively working on it, but while simultaneously keeping the perspective of the timeline over which these things might pan out, right? So many of the issues that you're raising, I do think 5-10 years from now, we'll probably have a bit more of accepted terminology. And as more and more people think about these problems and want to standardize them. I know that it may be an unsatisfactory answer, but it's a very high level one.
And we have armies of PhD students and researchers to work on this.
Yeah, about maybe that, because the criticism I have to that, I would say, is that we live in a world where a lot of these incentives are profit-driven. So we basically make a lot of impact or like a lot of distance in those things that the companies are paying for. But I, for instance, work in responsible AI, and I really want to have a job in responsible AI, and yet cannot really find that yet, because like profit-driven companies would much rather kind of be, for as long as they can, basically be blind for a lot of the social aspects. And of course with regulation this will change, there will be incentives that might change, but in a grander scheme, like because it's touching on this idea of like tech is kind of neutral and we can just steer it in the way that we want to, but how do we make sure that like not all of our collective efforts go into that what the profit companies want us to do?
Irma, I think this is exactly why you should join these corporations, because they need you. You've got to change it from the inside out.
They don't want me.
No, but I mean, I'll tell you something. All of the very prominent talent tech companies we've spoken with, none of them have said to me, we do not have a problem. There is no bias. So even the AI companies are very, they're honest about that they have an issue. So you are like all you data scientists, PhD, you have to absolutely join these companies to turn them around from the inside out. And obviously we need regulations and I'm not saying we need policies, but this is how we make changes. I mean, the more people who are going to join these companies to make you click on things, right? Let's have these amazing bright minds join these companies that are really truly doing things that are impactful. And I agree with you, there's a timeline, but I also think AI has such an impact on us. And I've been even on the forefront of mobile internet in the 90s. And, if the mobile internet breaks, that's just tough luck. But if AI breaks, somebody could end up in prison innocently, right? So this is why I'm saying, Irma.
Take the next question. I think there are two. Yeah. Here, one there. Yeah, let's take the non-panelists first. And then.
Hi, I'm Paksy Plackis from AUMC. I'm working in AI and health. So the question is the following. We know bias and unfair diagnostic and prognostic tests, which 99.99, even more percent, they have been created, developed the last 30 years using regression models. So again, the input is data there, but of course it's not AI, as we call it today. And the question is, what has been done? If there is any interest of taking a look of these diagnostic tests regarding bias, because we use it every day.
Thank you for the question. I think healthcare is a very interesting domain because, of course, we have all these bias and fairness problems, but on the other side, I think it's pretty clear. Something is wrong with the microphone. Yes, maybe a bit far away. I think it's pretty clear also that maybe gender plays a role, right? So I think it's really hard to define fairness in the context of healthcare because there are gender-specific maybe diseases, and this should be taken into account also, right? And in the case that you mentioned, I think there are different interesting problems that need to be analyzed. For example, the history of the patient, right? So I think a very important part in healthcare is really how often do you see the patient, how long is the history, and maybe there is a difference also between private patients and public insurance patients because they go through different diagnostics. So is there any difference regarding the data that you collect from these patients, which have, of course, a clear impact on the results that we get from the models? And I think regression is a very nice model. I would say it's AI also, right? Because I mean it's one of the Supervised learning, right? So regression, one of the popular supervised learning techniques, and I think the problem is not really whether it's deep or shallow, it's really whether it serves the particular task. And deep regression is explainable, perfectly fine. But I think in this context it's really important to look at the data also from a history of the patient. Do you have the right diagnostics? What was the prescription? And does everyone, all the patients, independent of their, for example, age, healthcare status, whether they have the same access to the diagnostics? And then the problem becomes super hard because maybe you have patients with different feature spaces if they go through different tests. And you have really a lot of challenges also at the technical level. How do you compare people on a different feature space, for example? Right? It's not super easy. I'm not sure if I answered your question. I brought more questions actually, but I want to say it's a complex topic, it's super interesting.
Thanks. The thing is I've seen, because it's also a buzzword and everyone tries to take advantage of AI in the last 3 years, I would say. And now with ChatGPT, everyone is AI expert actually.
Yes.
So the question is exactly, linear regression, it is a machine learning technique. It's there 30 years, even more. They have a diagnostic test. We use them, and not only gender perspective, but age. And a pathologist, for example, they know, depending on the age, is biased. So you can start getting drugs, but you are healthy. But because the primary care did this test, you have to take drugs, right? Because there's a threshold. So what I'm trying to say is maybe we have to be more aware, not only from AI as we see in the last years, but conventional approaches which are there 30 years, and we actually use them in drugs and actually health impact, right? Independent of the gender, nobody says anything about it. And it's clear, I know, I work in health, AI, it's there, and if you talk to epidemiologists, they know there is a fact. They have been talked about bias even 10 years ago, but actually nobody listens. So my question is, I really like the AI Act, but what about conventional non-AI Act? It's not there yet, and nobody even discuss about that. So I would wonder if any one of you would be interested in initiate the project, because I'm working with these kind of things, which are really crucial for humanity.
I'm not entirely sure if it wouldn't be covered, because on my right side I hear somebody say, this is AI. You say, this is not AI.
No, it is AI for us, that we know it is, but for 99% I think it's not.
Yeah, so if it is, and if it's covered, this is a whole different discussion under the AI Act, whether the definition covers everything that we really want to cover. But let's assume that it is covered. Then there is also, I think this would be a public organization. No, I think that you would have to check your systems also against the AI Act if it's used in a hospital. So if it's used in private and already exists, it's not included, it's not covered. But if it's used in a hospital, I would say that there needs to be some sort of exercise where you do exactly what you just mentioned. You look at these systems and you look at, do they fulfill the requirements, however perfect or imperfect they are at this moment, the requirements of the AI Act, because it would be a diagnostic system in healthcare, so it would be a high-risk system with a lot of requirements.
I'm interpreting your question as like you're using the term like modern AI kind of a thing, right? Like so I think it's useful to be a bit cautious here, because traditionally, if you look at models, like regression models and so on, they had a very clear notion of bias and variance and how there are trade-offs and so on, right? So, but I think when we talk about machine learning, which is a way in which you design the AI systems, where you're letting machines search for the optimal decision procedure, as opposed to specifying it ahead of time, then all of a sudden you have bias in objectives, which is a different type of bias than the bias and variance that people talk about in the regression models. And for the community, this took a long time to recognize that there can be bias in the way objectives are defined in machine learning, And this may be different from the traditional bias and variance in statistical models. And then with deep learning, there is a new type of issues that come up, right? Because traditionally with machine learning, as a machine learning engineer, you would spend a lot of time precisely specifying what are your input features. Whereas with deep learning, the one thing that people started doing is not even specifying the input features. Instead, letting the machines, once again, search through the whole space to find what the features are. Now, naturally, there is a new types of biases that came in, which are related to representational alignment, right? Like these are the ones where we have no idea what features they're using. And this is why all of a sudden, explainability, interpretability came out of nowhere with deep learning. And then when we go to foundational models, there is another deeper thing that is changed, right? This is one where traditionally in supervised learning, like with deep neural networks, whenever you would want to try to fine-tune it to a task, you would change and retrain the model, the weights, at least parts of the model. Whereas with foundational models, the thinking is that, well, it has the world knowledge, and so we don't even do fine-tuning, but instead we do this, I mean, they use all types of jargon, like a few shorting and these sorts of things. Now, what sort of biases does this bring in? Quite honestly, I don't think we understand the new types of biases that are coming in with foundational models. And here, we should also remember that when you're going to foundational models, all of a sudden you're going from supervised learning to unsupervised learning with generative modeling. And all of a sudden, the entire mathematical framework that we have about pack learning that works for supervised learning does not apply for foundational models. So now, who the hell knows what are all the new biases that come in, right? And so I think there is a lot of foundational work that needs to be done in terms of understanding more clearly what types of biases come in with every new generation of AI systems, and in terms of having a more clearer idea of what are the parts where the human or the experts are specifying to the systems and which parts aren't.
Yeah, I have, I guess, sort of a question / proposal regarding how we think about decision making using AI. Because we kind of mentioned this question of, is the model better than the human, or is the combination somehow better than just one of them alone? And then we also, you mentioned sort of the more trust in collaborative decision making, and then also this idea of algorithmic heterogeneity or so that there's, which kind of brings to light that there's not one right algorithm or one right ranking or anything like that, but there is danger in having one single algorithm scaled up to, supersede everything else, right? And one little exercise we did at a co-creation workshop was where we just had groups of different stakeholders together, and they had this mock tool, and they could sort of get a sort of presentation of job applicants according to whatever sort of values and preferences they specified, with a sort of trying to generate like an explanation for why the candidates were presented in this way according to this set of values. Because obviously the way the information that's presented to the human decision makers influences the decision maker, their decision, what their attention is drawn to. And I guess my question / proposition is, like, what do you think about the idea of collaborative decision making that involves basically multiple algorithms and multiple people, and is a sort of deliberation kind of tool?
So just to begin with, even when we did this exercise for this project, it's happening now. There is no, you present your, your resume or your data or even how you want to come across. There's passive databases now, and there's companies that are using that to offer up people to companies. So in the very near future, you're not even sending in, nobody's gonna even look at your resume, basically. So we're gonna enter a whole new world in how you see yourself, or how you're presenting yourself now, or the way you think I'm fit for this job is not even up to you anymore. So I don't know if that's, I'm just saying there's this next level of recruitment, of hiring. I mean, it starts with these ads. It starts with who sees what opportunity. So I'm getting presented opportunity of 6 figures, but my neighbor is not, even though we're equally qualified. So it starts with that already. And then it goes on to who gets invited. And then you have another algorithmic system that decides, a tool that decides, and based on other large language models, etc. This is what you're saying, right? There's a multitude of different tools that make decisions that base their decisions on whatever criteria, whatever language model you used. My only question is, aren't all LLM currently from corporations that even though you are making the system learn for your company, the underlying data is a foundational data set, I'm looking at you, right? From a certain corporations that it's a set of values that have been preset by the top 3 companies in the world. So that's already the problem. Do we have a European or a Dutch data set that it's just not based on ChatGPT or Microsoft or whatever, right? Or Google. So that's 1. 2, you're gonna see in the hiring, so sourcing, screening, right? Selecting, they're all different models, different sets of tools. And then you're gonna have, and this is the next iteration that, the big companies like Amazon are doing already, they're testing with who should be trained in what, not because you want to, but because we think as a company, you are right for this senior manager role, because you look like the other successful people we've had in this position. Well, we've seen in the past, if your successful manager is predominantly white and predominantly male, then what does that mean for the rest of us? And then it goes to package, promotion, salary. Your salary now is going to be decided by the data we have on you, and then, so these are all different models, all different tools, all different. So I know it complicates it even further, and I don't know if I answered your question, but what was the question?
It was slightly different. It was kind of in a sort of smaller scope for, one step of the process, if we're not using a single tool, but actually, kind of having a sort of deliberative tool that is kind of presenting different sides of the data we have.
Yeah, that's why you opened up a whole Pandora. For me, it's like...
I think what you said is really whether we can have a team of experts solving the same problem from different angles somehow, right? This could be an idea, right? And this is an idea that already exists in the context of machine learning. So methods, for example, right? They combine many different models, and the main idea is that each model in isolation is not sufficient to solve the problem, so each model looks at different, let's say, aspects, different views, and collectively, it's like checking with multiple doctors, right, to decide what to do, right? I think this makes sense. So this is one idea, that you can have indeed an ensemble of different experts, and then you can make a decision based on these different experts. I think there is another interesting aspect regarding this team of experts. It's not really a team, but actually all these models, they are just one instance of a possible model. So I call this hypothesis space, right? So you are looking for a model in a big hypothesis space. You find the model is not the global optimal model, right? It's a local optimal among many other possibilities, right? So we are not even sure if we pick up the right model. And in many cases, actually, you need there are also a lot of works in this direction of multi-objective optimization, and here actually I talked about many different objectives, right? So many of these problems could be phrased really as multi-objective optimization problems, where you cannot find a model that is best with respect to everything, but you find a Pareto front, and then you have models that are good with respect to certain aspects, but there is no improvement with respect to all aspects, right? So you can choose from the Pareto front, for example. So I think this is an interesting possibility, to combine different experts in all different ways, also by fine-tuning global models with company-specific data, right? I think we have really a lot of options, but I think we don't have a good orchestration somehow of all these models and whom to trust and how to combine all this, let's say, collective intelligence.
If I can add to that, and also to what you just said, because the already infamous AI Act of last week deals exactly with all this. It classifies everything that you mentioned as high risk, everything from the placing of the ads to the selection model to AI at the workplace, everything is high risk. And then you would say, okay, and then what happens? Well, what happens is that the European Commission decided to then lay down very, very specific, granular requirements for these systems to be able to enter the European market. And you can think of requirements around, for example, data. It requires data relevance, representativeness. As far as possible, the data should be complete. It should take into account the geographic relevant elements, the functional elements in which the algorithm or in which the system works. And if you build upon foundation models, they call it in the Act general purpose AI models, but those are the foundation models, and you want to use it again in this high risk environment, you have to make sure that OpenAI and Microsoft tell you what kind of data the foundation model was trained on, so that you can build the system in line with the requirements that the AI Act sets. So whether this is all feasible from a technical perspective is up to you all, I think, but the regulation foresees all this at this point.
I think it's really impossible to understand the flow of the data in these systems, right? So I'm thinking now of ChatGPT, and I mean, it was trained with everything from the web, and it's trained also, or it's updated through human feedback through these sessions, right? So the conversational sessions, and there is also an RL component where they modify or they fine-tune with human curated feedback. So I think it's really impossible to have an understanding of what goes in and out of these systems, and there are so many places for manipulation or for interventions, let's call it interventions.
Yeah, I fully agree, and I can imagine that it is very difficult, but what the European Commission took as a starting point is the protection of fundamental rights and the protection of people in sensitive relationships, such as the relationship with an employer, or the opportunity of getting a job, or the opportunity of getting social benefits, or when you encounter law enforcement, or when you are in migration. In these areas, the Commission said, in these areas we prioritize fundamental rights and the protection of fundamental rights, and technical limitations, we don't really care. I mean, if there are technical limitations, then obviously you cannot produce a system in line with fundamental rights. So sorry, or you have to build a better system. So that is the balance, and that is the new balance that needs to be sought. And if it ends up that you cannot use a system that was trained on an OpenAI foundation model because you cannot explain what went into the system as training data, etc., then the Commission will say, too bad, you cannot use the system for your particular tool, because you have to comply with these rules, because we prioritize the protection of fundamental rights in this case.
So sad, it helps us writing nice emails.
Sorry?
It helps us writing nice emails. So sad, like if it cannot be used. So.
Thank you very much. So this is the end of the panel. Let's thank the panelists, please.